Welcome to our third and final video on graphing rational functions for this virtual learning assignment. So we already looked over the graphic organizer and an introduction, and we also already did some practice just finding the characteristics. So now we are going to find our characteristics and draw the graph. So let's get started. Number one, first step, always factor and cancel first. So on the top, we have a greatest common factor of 12. So if I factor that out, you have x minus 2. On the bottom, we have a greatest common factor of 4. So if we factor that out, we have x plus 3. So the only thing that simplifies here is the 12 over 4. And 12 over 4, 12 divided by 4 is just 3, or 3 over 1. So we only have a 3 on top and an understood 1 on the bottom with our x plus 3. We did not cancel any factors that included an x, so that means we will skip steps 2 and 3, which means we do not have a hole in our graph. We said in the last video, RD stands for removable discontinuity, and that's the hole in the graph. So because we didn't cancel any factors that had an x in it, we do not have a hole. So we'll put NA, or we'll write none. We'll just put a little note saying there isn't one. So now we can skip down to step 4. Our vertical asymptote. We said this is found by setting the denominator equal to 0. So if we take the denominator of our reduced function here and we set this equal to 0, and then solve for x, we get that x equals negative 3. So this is our vertical asymptote. Our next step is step 5. Find the x-intercept. We're going to set the numerator equal to 0. So if we set these factors equal to 0, that'll tell us the x-intercept. So 3 equals 0 doesn't have an x to solve for, so we're not going to worry about that. So the x minus 2 we will set equal to 0 to solve for x, and we get that x equals 2. So when you set the numerator equal to 0, that x tells us our x-intercept. Remember, on this list here, we don't have something that says x-intercept, but we know that zeros means x-intercepts. So we know that our x-intercept, or our 0, is at the order pair 2, 0, because that x-coordinate is 2. On our graphic organizer, our next step is finding the y-intercept. We said plug 0 into our reduced function to get the y-intercept. So our reduced function here, we start with 3, and then x minus 2. We're going to plug in a 0 there, 0 minus 2. On the bottom, we need to plug in a 0 here as well, so 0 plus 3 is on the bottom. So on the top, you have 3 times negative 2, and on the bottom, 0 plus 3 is 3, so that gives us negative 2. So this is our y-intercept. And remember, with the y-intercept, 0 goes first, and then your value. 0, negative 2 is the y-intercept. And the last thing on our graphic organizer up here, find the horizontal asymptote. So this, we said, is where we look at the degree of the numerator and the denominator. The degree is that biggest exponent. So the degree of this x is 1, the degree of that x is 1. So this is when we look at the leading coefficients. So you have a 3 as a leading coefficient on the top. You have an understood 1 on the bottom. 3 divided by 1, or 3 over 1, is just 3. So our horizontal asymptote is at y equals 3. So after we find everything, now we have to actually put everything on the graph. Okay, so vertical and horizontal asymptotes are dotted lines. Remember, those are boundary lines our graph is going to get really close to, but never touch or cross. So vertical, remember, goes up and down. We're going to cross through the x-axis at negative 3. So at negative 3, we're going to cross through that x-axis at negative 3, and we're going to draw a vertical asymptote, which is just a vertical dotted line through the x-axis at negative 3. The horizontal asymptote is at y equals positive 3. So we're going to cross through the y-axis at positive 3, and we're going to draw our horizontal asymptote. Remember, horizontal goes left and right. I always think of the horizon when I see horizontal. That's how I know it goes left and right. The zeros are our x-intercepts. Remember that order pair you just plotted as a point. So 2, 0. So 2 zeros right here. So our graph is going to touch the x-axis right there at 2, 0. There isn't a hole, so we don't need to draw anything for that. And then our y-intercept is at 0, negative 2. So 0, negative 2 is right here on the y-axis. And then we know that for these basic rational functions that we're graphing in this lesson, they're going to look like this every time. You're going to have your horizontal and your vertical asymptotes, and then you're going to have two curves that are opposite from each other, that curve and get really close to those asymptotes but never touch or cross them. So they could be here and here, or sometimes they could actually be drawn up here and over here. But they're always across from each other like this. So if we look at this, we have dots here. So we know that our one curve is going to be over here. And we're not going to worry about getting any other points. We're basically just sketching. We're not making a perfect graph. We're just going to make sure our characteristics are in the right place. So we're going to draw a curve. It's going to get really close to those asymptotes, but it's never going to touch or cross them. So if there's a curve down here, then we know that there has to be a curve up here as well. And I'm not going to make you plug in numbers and find extra order pairs or anything like that. You just need to draw it in. So there should be a curve here and there should be a curve up here. So just sketch it in there so that you are showing that you know, hey, there's another curve up here. All right, let's look at the second example. So, first things first. If you need to look at your graphic organizer to go through the steps, then look at your graphic organizer. Step 1, factor and cancel anything that you can. So on the top, the first thing I notice about the top is there's a greatest common factor of a 2. So I'm going to factor that out first. So we have x squared plus 5x plus 6. On the bottom, we don't have a greatest common factor. So we have 3 terms. That's quadratic. We need 2 numbers that multiply to 2 and add to 3. So 2 times 1 gives me 2. 2 plus 1 gives me 3. So we have x plus 2 and x plus 1. So on the top, you notice we have another quadratic just like the bottom here. So we need 2 numbers that multiply to 6 and add to 5. We need a factor more. So let's see here. We need to multiply to 6 and add to 5. So that'll be a 2 and a 3. 2 times 3 gives you 6. 2 plus 3 gives you 5. So on the top, we have the 2 as the greatest common factor in the front. And then the 2 numbers we found were 2 and 3. The bottom, we factored into x plus 2 and x plus 1. So I'm going to leave that like that. And what do you notice? We do have something that cancels. So what's left on top here? We have a 2 and an x plus 3. And on the bottom, we have just x plus 1. Sorry, I got kind of crooked there, but I was trying to avoid writing on the graph. So this is the reduced function that we're going to be using to find our characteristics. Now, remember, if we cancel something out, then that means we have a hole in the graph. So if we have a canceled factor, we need to set that equal to 0 to get the x coordinate of the hole. So if we take our canceled factor, x plus 2, and I'm just going to do some work over here. If we take that canceled factor, x plus 2, and we set that equal to 0, then we solve for our x and get that x is negative 2. So remember the RD, that removable discontinuity, is your hole. So this negative 2 is the x coordinate of that hole. If you don't remember how to find the y coordinate, look at your graphic organizer. Step number 3 says to find the y value of the hole, we're going to plug in the x that we just found into the reduced function. So the x value that we just found was negative 2, so we're going to plug that in up here for both of those x's. So we have a 2 times, and then x plus 3, we'll plug in a negative 2 there. So it'll be negative 2 plus 3. And on the bottom, we need to plug in a negative 2 for this x, negative 2 plus 1. So we need to add these. So on the top, we have 2 times 1. On the bottom, we add those, we get a negative 1. So 2 divided by negative 1 is negative 2. So negative 2 is the order pair of the whole. All right, going to the next step. After we find the whole, step 4 says vertical asymptote. To find that, we set the denominator equal to 0. So in the denominator, we have x plus 1. So we'll take x plus 1 and we'll set that equal to 0. So we get x equals negative 1, and that's the vertical asymptote. For the next step, the x-intercept is next. So we need to set the numerator equal to 0. So if I take this numerator and set these factors equal to 0, I will get that x-intercepts. So 2 equal to 0, that's not going to have an x to solve for, so ignore that. And then x plus 3, we're going to set equal to 0. So if I set x plus 3 equal to 0, and I solve for x, I get x equals negative 3. So remember these zeros here, those are your x-intercepts. So our x-intercept is at negative 3, 0. The next step says to find your y-intercept. So to do that, we're going to plug in 0 into our reduced function. So we'll substitute the 0 for these x's here. So we have 2 times, and then 0 plus 3 on the top, and on the bottom we'll have 0 plus 1. So you have 2 times 3 on top, and you have 1 on bottom. So that'll be 6 over 1, which is just 6. So remember, this is the y-intercept, right? So it's going to be 0, 6. And last but not least, step 7, find your horizontal asymptote. So to find the horizontal asymptote, we look at the degree of the numerator and the denominator and compare them. So if we look at the degree of the top, we have a 1. The degree of the bottom is a 1. So we said if the degrees are the same, that means we have to look at the leading coefficients. So the leading coefficient on the top is this 2 here. The leading coefficient on the bottom is a 1. So 2 divided by 1 is 2. So y equals 2 is the horizontal asymptote. Once you find everything, now we can put it all on the graph. So the vertical asymptote, remember that's a vertical line, and we're going to draw it as a dotted line. We're going to cross through the x-axis at negative 1. So on the x-axis at negative 1, we're going to draw our vertical asymptote. Remember, it's a dotted line. And I put arrows because it does go forever. The horizontal asymptote is at y equals 2. So on the y-axis at positive 2, we're going to draw our horizontal asymptote. So remember, this is also a dotted boundary line. Our zeros, or x-intercept, is at negative 3, 0. So 1, 2, 3, negative 3, 0. On the x-axis is the x-intercept. Ooh, we have a hole on this one. So remember, the hole is going to be a point that is open. It's going to be a gap in the graph. So negative 2, negative 2 is the order pair of our hole. So negative 2, negative 2, there's a hole in our graph right there. Then the y-intercept is at 0, 6. So on the y-axis, up at positive 6, that's our y-intercept. So once we have everything plotted, now we know it's supposed to have this shape with these two curves. This particular one, instead of being down here and up here, for number 2, we're in this quadrant here and this one up here. So we'll just try to connect our dots here. Remember, you get really close to that asymptote, but you don't actually touch or cross it. And then this one curves this way. So they get really close to those asymptotes, but they don't actually touch or cross it. And if you notice, I did not draw my line straight through that hole. It's a gap in the graph. You have to pick up your pencil. You can't just draw the graph right through the hole. It needs to be open. It needs to be a gap in the graph. And then up here, we'll just draw in our curve. So we know we have to get close there and cross through there and then make it curve down this way. So gets close to those asymptotes, but it's not going to actually touch or cross them. So that's number 2. Hopefully this was helpful. If not, shoot me an email and I will do my best to email you back with any help I can offer. Have a great day.